1.6.4. Adding and subtracting rational expressions. Adding and subtracting rational expressions works just like adding and subtracting numerical fractions. To add fractions, we need to find a common denominator. Let's look at an example of fraction addition. 5 over 24 plus 1 over 40 equals 25 over 120 plus 3 over 120 equals 28 over 120 equals 7 over 30. We have to rewrite the fractions so they share a common denominator before we are able to add. We must do the same thing when adding or subtracting rational expressions. The easiest common denominator to use will be the least common denominator, or LCD. The LCD is the smallest multiple that the denominators have in common. To find the LCD of two rational expressions, we factor the expressions and multiply all of the distinct factors. For instance, if the factored denominators were open parenthesis x plus 3 closed parenthesis multiplied by open parenthesis x plus 4 closed parenthesis and open parenthesis x plus 4 closed parenthesis multiplied by open parenthesis x plus 5 closed parenthesis, then the LCD would be open parenthesis x plus 3 closed parenthesis multiplied by open parenthesis x plus 4 closed parenthesis multiplied by open parenthesis x plus 5 closed parenthesis. Once we find the LCD, we need to multiply each expression by the form of 1 that will change the denominator to the LCD. We would need to multiply the expression with a denominator of open parenthesis x plus 3 closed parenthesis multiplied by open parenthesis x plus 4 closed parenthesis by x plus 5 over x plus 5, and the expression with a denominator of open parenthesis x plus 4 closed parenthesis multiplied by open parenthesis x plus 5 closed parenthesis by x plus 3 over x plus 3. How to? Given two rational expressions, add or subtract them. 1. Factor the numerator and denominator. 2. Find the LCD of the expressions. 3. Multiply the expressions by a form of 1 that changes the denominators to the LCD. 4. Add or subtract the numerators. 5. Simplify. Example 4. Adding rational expressions. Add the rational expressions. 5 over x plus 6 over y. Solution. First, we have to find the LCD. In this case, the LCD will be xy. We then multiply each expression by the appropriate form of 1 to obtain xy as the denominator for each fraction. 5 over x dot y over y plus 6 over y dot x over x. 5y over xy plus 6x over xy. Now that the expressions have the same denominator, we simply add the numerators to find the sum. 6x plus 5y over xy. Analysis. Multiplying by y over y or x over x does not change the value of the original expression because any number divided by itself is 1, and multiplying an expression by 1 gives the original expression. Example 5. Subtracting rational expressions. Subtract the rational expressions. 6 over x squared plus 4x plus 4 minus 2 over x squared minus 4. Solution. 6 over open parenthesis x plus 2 closed parenthesis all squared minus 2 over open parenthesis x plus 2 closed parenthesis multiplied by open parenthesis x minus 2 closed parenthesis. Factor. 6 over open parenthesis, x, plus 2, closed parenthesis, all squared, dot, x, minus 2, over, x, minus 2, minus 2, over, open parenthesis, x, plus 2, closed parenthesis, multiplied by, open parenthesis, x, minus 2, closed parenthesis, dot, x, plus 2, over, x, plus 2. Multiply each fraction to get LCD as denominator. 6 times, open parenthesis, x, minus 2, closed parenthesis, over, open parenthesis, x, plus 2, closed parenthesis, all squared, dot, open parenthesis, x, minus 2, closed parenthesis, minus 2, times, open parenthesis, x, plus 2, closed parenthesis, over, open parenthesis, x, plus 2, closed parenthesis, all squared, multiplied by, open parenthesis, x, minus 2, closed parenthesis. Multiply. 6x, minus 12, minus, open parenthesis, 2x, plus 4, closed parenthesis, divided by, open parenthesis, x, plus 2, closed parenthesis, all squared, multiplied by, open parenthesis, x, minus 2, closed parenthesis. Apply distributive property. 4x, minus 16, over, open parenthesis, x, plus 2, closed parenthesis, all squared, multiplied by, open parenthesis, x, minus 2, closed parenthesis. Subtract. 4 times, open parenthesis, x, minus 4, closed parenthesis, over, open parenthesis, x, plus 2, closed parenthesis, all squared, multiplied by, open parenthesis, x, minus 2, closed parenthesis. Simplify. Q and A. Do we have to use the LCD to add or subtract rational expressions? No. Any common denominator will work, but it is easiest to use the LCD. Try it number 4. Subtract the rational expressions. 3 over x plus 5 minus 1 over x minus 3. 1.6.5. Simplifying complex rational expressions. A complex rational expression is a rational expression that contains additional rational expressions in the numerator, the denominator, or both. We can simplify complex rational expressions by rewriting the numerator and denominator as single rational expressions and dividing. The complex rational expression a, divided by 1, over, b, plus c, can be simplified by rewriting the numerator as the fraction a, over, 1, and combining the expressions in the denominator as 1, plus bc, over, b. We can then rewrite the expression as a multiplication problem using the reciprocal of the denominator. We get a, over, 1, dot, b, over, 1, plus bc, which is equal to a, b, over, 1, plus bc. How to? Given a complex rational expression, simplify it. 1. Combine the expressions in the numerator into a single rational expression by adding or subtracting. 2. Combine the expressions in the denominator into a single rational expression by adding or subtracting. 3. Rewrite as the numerator divided by the denominator. 4. Rewrite as multiplication. 5. Multiply. 6. Simplify. Example 6. Simplifying complex rational expressions. Simplify. Y plus 1 over x divided by x over y. Solution. Begin by combining the expressions in the numerator into one expression. Y dot x over x plus 1 over x. Multiply by j to get LCD as denominator. xy over x plus 1 over x. xy plus 1 over x. Add numerators. Now the numerator is a single rational expression and the denominator is a single rational expression. xy plus 1 over x divided by x over y. We can rewrite this as division and then multiplication. xy plus 1 over x divided by x over y. xy plus 1 over x dot y over x. Rewrite as multiplication. Y, open parenthesis, xy, plus 1, closed parenthesis, over x squared. Multiply. Try it number 5. Simplify. X over y minus y over x divided by y. Q&A. Can a complex rational expression always be simplified? Yes, we can always rewrite a complex rational expression as a simplified rational expression. 1.6.6 Media. Access these online resources for additional instruction and practice with rational expressions. Simplify rational expressions. http://openstacks.org/l/simpratexpress. Multiply and divide rational expressions. http://openstacks.org/l/multdividex. Add and subtract rational expressions. http://openstacks.org/l/addsubratex. Simplify a complex fraction. http://openstacks.org/l/complexfract.